Hi, this is introduction to game called Flowshop Scheduler. So it's a simple introduction to how production scheduling can take place in a Flowshop. And we have a simple example here of three machines in a layout of a Flowshop. We have 10 jobs, not too many, and then we can play around with the scheduling here and test some scenarios. So let's start with launching the game or the scheduler, maybe it's more like a simulator or something like that. And here we have our three jobs, three machines, M1, 2, and 3. We have now, according to first come, first service sequence, the jobs. So the first job here, up front here, the red one, is job number 1. So it will first be completed in the first machine, then it will flow to the second machine, and then third machine, and then it's completed. Job number 2 following that. The processing time here is a little bit shorter for job number 2 in the second machine, and the second machine will be a little bit idle here. We can see also some idle time here in the beginning for for any jobs in second machine here, and some other holes here, like between job number 5 and 6 over here. And we have the times here, the processing times for each of the job. And if we want to change the schedule, perhaps we would like to improve the total processing time, basically the time it takes to complete all the jobs, which we call here make span. So over here it's now 74 time units to take care of all of this. We can adjust the processing times here. For example, we can make, let's say, job number 6 here has 7 time units of processing, so we can make it shorter. And then we can take job number 7, make it even longer. Let's see what will happen now. We can see that machine number 3 will have idle time because it takes a long time according to this to take it. And then we have also due date. We can give the due date when we actually promise to our customer when the job will be completed. So this can be also adjusted, and they can be used in some of the scheduling cases. Now we can use some simple rules like the shortest processing time. So now, instead of having the first come first service, we can use this one to have the sequence of operations at whatever had the shortest time. And now we can see that it's a little bit different. Now we take job number 10 first, then job number 6, 2, 4, and so on. Okay, now it's 82. Before it was 85, so a little bit shorter. We can do the same thing around the other way around. LPT, longest processing time here, 90. And now we can also see the average tardiness, which refers to how much our customer orders are late from the due date. The due date what we promised to our customers. So what is the actual delivery time? And if we compared, I think the previous one, the SPT would give the number of 7.4 time units late, and first come first serve. Okay, it would be a little bit worse also on that one. But what we can do here in scheduling, we can change the sequence of operations. So we can just take like the manual way. We just drag and drop this. We can change the sequence, and perhaps we are able to change some of the parameters. So now our performance indicators show, okay, 86 and average of 90. So we have some things which are still late, and the total time is 86. But what we what we can use in scheduling is of course some computerized solution. And here we have a simple search algorithm. Okay, it's not going to guarantee any optimality for the solution. Just using some computer science technique to uh, find a solution which will be minimizing the make span, the total time it's spending here. It doesn't care actually at all the average tardiness. This is like a simple demonstration only. So when I press this one, okay, it will achieve 74 and 8. So probably I think there would be some better solutions as well, possible as well. And if we care about the average tardiness, so perhaps it would be possible to make it okay, like this one actually showing pretty good performance EDD, which is it's just a simple rule to take the earliest due date. So take the orders according to the uh, time what we have promised for our customers. So yeah, a simple tool you can play around with that, and uh, but it's limited. It's limited. It's only the flow shop, so all the jobs must be going through the same sequence. We can't skip any of those. Okay, unless you give zero value. I think that would kind of be a workaround for that, and only 10 jobs, which is pretty minimal for I think any factory, but. Also for implementation, if you're interested to see the source code, it's fairly simple to see and expand this concept by using some AI tool if you are willing to build a proper solution for production scheduling. And okay, we have a randomizer here, so if you want to have new problems, so just press a button and it will generate you some alternative problems, or just manually you can edit this stuff here. Very good. I hope you enjoy this. Thanks.